Okay, so this is a video on trigonometry. You can find this PDF booklet on MathsUpgrade.co.uk under the Geometry and Measures section. So the first set of questions are non-calculated questions. Question 1 asks us for the exact value of cos 30. Okay, so these are values that you should be able to recall for the exam. Okay, so the exact value of cos 30 is root 3 over 2. Okay, so that's root 3 over 2. Part B. Given that sine 30 equals 0.5, work out the value of x, and this is for 2 more marks. So the first thing we're going to do is we're going to label this triangle from the point of view of this angle. So imagine you're standing on this angle, okay? The first side we're always going to label is the hypotenuse, because that's the longest side and it's opposite the right angle. So that's the hypotenuse there. The side opposite to us is this side here, and this side is the adjacent. So let's label them like that. So we've got hypotenuse and opposite from the point of view of the angle given to us. I haven't labelled the adjacent because actually I'm not given the value for it and I'm not asked to work it out. So I don't actually need to label the adjacent at all. Now since I need to work out the opposite and given the hypotenuse, I need to use SOH, so it's sin. Okay, so sin is equal to opposite divided by hypotenuse. That sin of the angle is equal to the opposite, which is x, divided by hypotenuse, which is 12. If I rearrange this to make x the subject of that equation, then x equals 12 times sin 30, since I'm going to multiply both sides by 12. Substituting sin 30 equals 0.5 as given in the question gives me 12 times 0.5, which would be 6. And the units here, since it's a length, are the same units given in the question, which in this case is centimetres. The whole question there is worth 3 marks. Question 2. Again, a non-calculated question. I have to find the exact value of tan 30 multiplied by sin 60. Give my answer in its simplest form. Okay. Well, you need to recall these two values, tan 30 and sin 60, and their values are here. Tan 30 is root 3 over 3, sin 60 is root 3 over 2. If I'm then going to multiply these two expressions together, I end up with this here. So I'm putting them as just one single fraction, which would be root 3 all over 3 times 2. Well, the numerator there, root 3 times root 3, is just the same as 3. Okay. If you're unsure on how that is, you need to look at my video clip on surds, which explains that. And then the denominator, 3 times 2 is 6. So 3 over 6, if I simplify that in its simplest form, this would be a half. That whole question there is worth 2 marks. Okay, question 3. Again, another non-calculated question. This is probably the hardest non-calculated question there is in this booklet. So I'm given a diagram there which has got 3 right angle triangles inside it. Okay, and each right angle triangle has got an angle of 30 degrees also. So that's 30, that's obviously a right angle, so this must be 60 degrees. And that's similar for all of them. Okay, since all the triangles have all got the same 3 angles in them, these triangles are all similar to one another. Okay, and I'm also told that this length here is n and the length of this side here is y, so they've been labelled up. I have to prove that y is equal to 3/4 of n. So with this question, what I'm going to do is I'm going to label these 3 triangles as just triangle 1, 2 and 3. Okay, triangle 1, 2 and 3. And from the point of view of this 30-degree angle here, for this first triangle, this side y must be opposite to me, and this side here is a hypotenuse. I'm just going to label that side there as A. So for triangle 1, just focusing on triangle 1 for now, to relate the opposite and hypotenuse, I need the sin ratio. So sin equals opposite divided by hypotenuse, and it's the sin of the angle 30, which equals the opposite, which is y, divided by that letter that I've designated to it, which is A. So sin 30 equals a half. You should be able to recall that information because you need to know that for the exam. So a half equals y over A. So therefore A equals 2y. So A equals 2y. So now I've got this term here in terms of y here. So know this side in terms of y. Now for triangle 2, I'm going to do something similar. So here's triangle 2. Okay, again, I'm given an angle of 30, and I know that this side here is now adjacent to me. It's adjacent, it's next to me, okay, next to the angle. This side here is the hypotenuse, because it's the longest side, it's opposite the right angle, and I'm labeling this hypotenuse as B. Okay, so for triangle 2, I need to relate the adjacent angle, the adjacent side here, with the hypotenuse. Adjacent and hypotenuse are related using the cos ratio. So cos equals adjacent divided by hypotenuse. If I substitute in the values, the cos of the angle, so cos of 30 equals the adjacent, which is A, divided by B. Well, I worked out that A is equal to 2y. If I substitute that into here, I've got 2y over B. And also cos 30, you should recall that cos 30 is the same as root 3 over 2. So root 3 over 2 equals 2y over b. If I rearrange this, then I get b equals 4y over root 3, simply by cross multiplying. So b equals 4y over root 3. So now I've got an equation which relates b to y. So relates this side here to that side there. And the third triangle now. The third triangle, triangle 3. Again, it's got an angle of 30 degrees here. Okay, this side here is now the adjacent for this triangle. Okay, and that's labelled as B. And this side here is the opposite, and that's already labelled in the question as N. So I need to get a relationship which relates the adjacent and the opposite. Opposite and adjacent are related using the tan ratio. So tan equals opposite divided by adjacent. And it's tan of the angle, so tan of 30 is equal to the opposite, which is N, divided by adjacent, which equals B. And I know from the previous working here, B is equal to 4y divided by root 3. So if I substitute that into here, B is equal to 4y divided by root 3. So that's the denominator of that fraction there. You should recall tan 30 is the same as root 3 over 3. So tan 30 is root 3 over 3. I've now got an equation which links N with y. All I need to do now to answer this question, I need to get it in this form. So to get it into that form, what I'm going to do here is quite simply I'm going to rearrange this fraction on this side here. Because I'm dividing by root 3, this is the same as multiplying the numerator by root 3. So root 3 over 3 equals n root 3 over 4y. Now the root 3's would cancel on both sides. So I can divide through by root 3 on both sides. That leaves me with the third equals n over 4y. Now, if I get y the subject of this equation here, multiply through by y, and multiply through by 3 on both sides, I get y equals 3/4 n. So that whole question there is worth 4 marks. It is a tough question, so make sure you follow it all through, and you'll get those 4 marks. So all of the remaining questions now are calculator questions, okay? So question 4 is just a simple matter of using a calculator and then rounding my answer. It asks me to work out that expression there, the cube root of 4.3 multiplied by tan 39, all divided by 23.4 minus 6.06. So I've got to give my answer correct to 3 significant figures. So what I'm going to do is my solution is I'm just going to work out the numerator of this fraction here, work out the denominator of the fraction, then I'm going to divide them through, and then I'm going to find the cube root of that as a final step. So the final step is always finding the cube root here. It's like having brackets around all of this. Okay, so that final answer is 0.5855, and when I round it to 3 significant figures, I'll get 0.586. The whole question there is worth 2 marks. If you're not sure what I've done there, look back on my YouTube clip on using a calculator, and that should help you further. Question 5. It's similar to question 4, where you have to use a calculator to work out the value of this expression. So again, using a calculator, I'm going to find first of all the numerator and also the denominator. Then I'm going to divide through, showing all my working out. And the final step is the square root. So when I square root, these are all the figures on my calculator display here for 2 marks. Then when I round this to 2 decimal places, I'll get 2.76. The whole question there is worth 3 marks. Question 6. I'm asked to work out the value of x here. So the first step here is to label the triangle. I'm labeling the triangle from the point of view of the angle. So imagine you're standing on this angle here. You need to decide where's the hypotenuse, so which is the longest side of this triangle. And the hypotenuse is this one here, since it's always opposite the right angle. So that's hypotenuse. Which side's adjacent to me? Here's the side which is adjacent to me. Which side's opposite to me? It's this one here. So I'm interested in both the hypotenuse, since it's given to me as a value, and the opposite, since it's what I'm trying to work out. Opposite and hypotenuse are related using the sin ratio here. So sin equals opposite divided by hypotenuse. And it's the sin of the angle, so substitute the angle into here. Opposite is given the letter of x, and hypotenuse has got a value of 18 centimeters. So substitute those into the formula here, then rearrange by multiplying both sides by 18, and I get 18 sin 30 equals x. So 18 sin 30 on the calculator, and I'd get 9 centimeters. It's centimeters since the question is asking for the length of this, and that's in centimeters as well. The whole question there is worth 2 marks. Question 7. Another right angle triangle. I'm going to find the length of AB. So again, the first thing I'm going to do is I'm going to imagine I'm standing on the angle that's given to us, which is here. We then need to label these sides. So the side which is the hypotenuse is the longest side, and it's opposite the right angle, so that's the hypotenuse there. The side opposite to me is this one, AB, and the side next to me is this one. This is the adjacent. So label up those sides like that. So hypotenuse is what I'm given in the question. Opposite is what I'm trying to work out, the length of AB. So knowing that opposite and hypotenuse are related using the sin ratio, sin equals opposite divided by hypotenuse, then substitute in the angle, so it's sin of the angle, sin 38, opposite is AB, and the hypotenuse is 16. Substituting those values in, and then rearranging by multiplying both sides by 16, I'll get 16 sin 38 equals AB, and evaluating that on the calculator and rounding to 2 decimal places, I'll get 9.85. That's in centimeters, and that's for 2 marks. Question 8. ABC is a right angle triangle. Calculate the length of AB. Give the answer correct to 3 significant figures. So again, I'm going to imagine that I'm standing on the angle here. So this side AC, this is the hypotenuse, since it's the longest side and it's always opposite the right angle. And AB is this side here, so AB is opposite to me, and BC is next to me, so that's adjacent. So I'm labeling those sides. The sides I'm interested in are the hypotenuse, since the value is given to me, and opposite, since that's what I'm trying to work out. So since it's the opposite and hypotenuse, they're related using the sin ratio. Sin equals opposite divided by hypotenuse. Substituting the angle, I'll get sin 23, and substituting in AB and 15 centimeters, I'll get sin 23 equals AB over 15. Rearranging this equation to get AB the subject of the equation, I'll multiply both sides by 15 to get 15 sin 23 equals AB. And then evaluating that on a calculator and rounding to 3 significant figures, I get 5.86 centimeters. And that question is 2 marks. Question 9. I'm given a right angle triangle PQR. I've got to work out the size of the angle marked X. Give my answer correct to 1 decimal place. So in this question here, I'm imagining I'm standing on the angle there, and I've got to label the sides according to my point of view. So side PR is the hypotenuse, since it's the longest side and it's opposite the right angle. So that's hypotenuse. Side PQ is opposite to me, so that's the opposite, and this remaining side QR is the adjacent. So labeling those sides up, I'll get this. Now I'm given the value of the hypotenuse and I'm given the value of the opposite. So hypotenuse and opposite are related using the sin ratio. Sin equals opposite divided by hypotenuse. Substituting the values for opposite and hypotenuse, I'll get sin of the angle X equals 5 over 14. Since this is the sin of the angle, I need to do the inverse of sin, which is shift and sin on my calculator. Shift sin, 5 over 14. Remember to close the brackets as well, and that gives me 20.9248. Rounding to 1 decimal place gives me 20.9 degrees, and that is 2 marks. Question 10. I'm given a right angle triangle, and I've got to find the size of the angle marked X. Give my answer correct to 1 decimal place. So in this question here, you've got to imagine you're standing on the angle. So let's imagine we're standing on the angle here. The side which is the longest side here is the hypotenuse. It's opposite the right angle always. So that's the hypotenuse. The side opposite to the angle is this side here, 1.9 centimeters. So that's the opposite. And this side BC is the adjacent side because it's next to me. It's adjacent to me. So labeling up the sides like that, I know that I'm interested in opposite and adjacent since they're the values given to me. Opposite and adjacent are related using the tan ratio here. Tan equals opposite divided by adjacent. Substituting the values for opposite and adjacent, I get tan of the angle, so tan of x equals 1.9 divided by 3/2. Since I need to work out the angle, I need to rearrange this to get x the subject of this equation. So the inverse of tan is shift tan, so shift tan 1.9 divided by 3.2. Remember to close the brackets on your calculator and you get 30.6997. Round to one decimal place, that gives 30.7 degrees, and that is 2 marks. Question 11. I've given a right angle triangle and I've got to find the size of the angle ABC. ABC is this angle here. So I'll have to label up the sides of this triangle according to my point of view. So imagine we're standing on the angle here. The hypotenuse is the longest side and it's always opposite the right angle. So 11 centimeters is the longest side, hypotenuse. This side next to me here is the adjacent, and the side opposite to me is AC, so that's opposite. So labeling the sides like that, I know that I'm interested in the hypotenuse since the value is given to me, and the adjacent since the value is given to me. Adjacent and hypotenuse are related using the cosine ratio. So cos equals adjacent divided by hypotenuse. Cos of the angle, so cos of ABC, is equal to the adjacent 7 divided by 11. Since this is the cos of the angle, I need to find the angle itself. So rearranging this, I need to do the inverse of cos, which is shift cos. So shift cos 7 over 11 equals 50.4788. So to one decimal place, that's 50.5 degrees, and that's 2 marks. The second part of the question states that the length of the side AB is reduced by 1 centimeter. The length of the side BC is still 7 centimeters. Will the value of cos ABC increase or decrease? You must give a reason for your answer. So just imagine if the length of the side BC is still 7 centimeters, but the hypotenuse is reduced by 1 centimeters. That means this here won't be cos of 7 over 11. It'll be shift cos of 7 over 10. Okay, so shift cos of 7 over 10. So in other words, this here will be cos ABC equals 7/10. So the hypotenuse has decreased to 10 centimeters. So the value of cos will therefore increase since 7/10 is bigger than 7/11. And that is 3 marks for the whole question altogether. Okay, question 12. So I've given a triangle PQR. The length of QR is 60% the length of PR. And we have to find the value of sin QPR. So the value of the sin of this angle. Correct to 3 significant figures. So this 60%. This 60% means that this length is 60% of this length. 60% of the decimal is 0.60, 0.60. In other words, 0.6. So this is 0.6. So if this is given a letter of A, this is going to be 0.6 times A. Okay, because 60% is 0.6 as a multiplier. If you're not sure on how I've got that, look back at the video clip on percentages on my YouTube channel. So now, if I rearrange okay, question 12. Here's a triangle PQR. The length of QR is 60% of the length of PR. Find the value of the sin of QPR. So that's the sin of this angle here. Give your answer to 3 significant figures. And this question is worth 3 marks. Now, this question is all about this 60%. 60% as a multiplier is 0.6. If you don't know where that comes from, if you're not sure on that, look back at my YouTube channel on the video on percentages, and that should help you with that. So this 60% we can write as 0.6. So if this is the length PR and this is the length QR, this length here must be 0.6 of this length. So if I give this a letter of A, this must be 0.6A. Okay, so here's the angle I need to find. Imagine I'm standing on this angle. This would be adjacent to me. This would be opposite to me. Okay, so the opposite is 0.6 lots of the adjacent. Now, how are the opposite and adjacent related? Well, they're related through the tan ratio. So tan equals opposite divided by adjacent. Since they're related using this 0.6, I can then substitute into this equation here. Tan of QPR, so tan of the angle, is 0.6A divided by A. And of course the A just cancels, so that's tan QPR equals 0.6. Now, since I need to get the sin of QPR, I'm going to rearrange this equation here so that QPR is the subject of that equation. So I need to get rid of this tan, and the inverse of tan is just shift tan. So shift tan 0.6 is equal to QPR, and that gives me a value of 30.96. Now all I simply need to do now is find the sin of that value. So the sin of that value is sin 30.96375, which is 0.5144957. Notice I'm writing quite a few digits here after the decimal point. Okay, I'll have to give my answer correct to 3 significant figures, so I'd recommend 4 or 5 significant figures within your working out at least. The whole question there is worth 5 marks. Question 13. The diagram shows 2 vertical posts AB and CD on horizontal ground. The post of AB has got a height of 1.7, and the ratio of CD to AB is 1.5 to 1. In other words, this post is going to be 1.5 times the length of this post. The angle of elevation of C from A is 52 degrees. What that means is the angle from between the horizontal and the direct line to AC is 52 degrees. Calculate the length of BD to 3 significant figures, and this would be 4 marks. So let me just, on my diagram, let me just show you what that would look like. So first of all, this is 1.7. Since CD is going to be 1.5 lots of AB, I can just do 1.5 times 1.7, which gives me 2.55. So that there is 2.55. Now I can find the length of CM, since I can do CD minus AB. So CD minus AB gives me 0.85. So that's that length there. Now, since the horizontal ground here and the post is vertical, this forms a right angle. So they're perpendicular to one another. So I've got a right angle here. And if I imagine an imaginary line going straight across here and the direct line from there to there, I've got a right angle triangle. Now this angle of elevation, like I said earlier, is the angle between the horizontal and the direct line from A to C. So that there is 52 degrees. So now with that angle and that right angle, I've got a right angle triangle. I can apply trigonometry now to the rest of this question. Since I need to work out the length of BD, that's essentially the same as the length of AM. Okay, since they're parallel and they're equal in length. So let's label this triangle according to the angle that I'm standing on. So imagine I'm standing here. This side is the adjacent to me, it's next to me. This side is opposite to me. And incidentally, this is the hypotenuse, but I don't need that for this question since I'm not asked to work it out and I'm not given the value for it. So the tan of CAM, so the tan of 52 is equal to CM, which is the opposite, which is 0.85, divided by BD, which is what I'm trying to work out. BD is the same as AM. So rearranging this, I can get the value of BD simply by doing 0.85 divided by tan 52. That gives me 0.664, and that would be 4 marks for this question. Question 14. The diagram shows triangle ABC. ADC and DEB are straight lines. So ADC and DEB are straight lines. AD equals 4.4, BC equals 8.6. E is the midpoint of DB. So E is the midpoint of this line here. and we're told that CDB is 90 degrees and DCB is 40 degrees. So essentially you've got a right angle triangle being formed here. Since this is a straight line here, this also must be a right angle triangle on this side as well. Work out the size of angle EAD. So work out the size of this angle here. I've got to give an answer to one decimal place, and the whole question is worth 4 marks. So in this question here, what I'm going to do is essentially I'm going to first of all find the size of BD, so the length of this line here. I can find that by looking at this right angle triangle here. So I'm going to find BD. After I found BD, I'm going to find the length of ED, since ED is just half of BD, it's the midpoint here. Then once I've found ED, I can find the angle EAD, since I would have got this side here, and I know this side, and this is another right angle triangle. So let's do that now. So starting with this right angle triangle here. Okay, imagine I'm standing on the angle here. This side would therefore be the hypotenuse, since it's opposite the right angle, and this length of BD would be the opposite. So I need to find the trig ratio which relates hypotenuse to opposite, and that of course is sin. So sin equals opposite divided by hypotenuse. So the sin of the angle, sin of 40, equals the opposite, which is BD, divided by 8.6, which is the hypotenuse. Rearranging that to get BD by itself as the subject of the equation, 8.6 times sin 40, I get 5.53. So BD is 5.53. Now, since ED is half of BD, because it's the midpoint here, then you know that ED is going to be half of 5.53, which is 2.76. So I've found ED now. That's critical to this question, because now all I have to do in this question is apply trigonometry to this smaller right angle triangle on the left hand side here. Now, with this triangle here, the size of the angle EAD, so imagine I'm standing on that angle. Let's label up the triangle again. So this side here is opposite to me, and this side here is next to me, it's adjacent to me. So the trig ratio which relates opposite with adjacent is tan. Tan of the angle there, tan of EAD, is ED divided by AD. Substituting the value of ED, which was 2.76, and the value of AD, which is 4.4, and then doing shift tan, since I'm finding the angle, I'll get an angle of 32.14 degrees. To one decimal place, that would be 32.1 degrees. And that would be 4 marks for the whole question. So essentially in that question, we've used trigonometry twice. Okay, question 15. So I'm given a trapezium here, and I have to find the size of angle CDA. So CDA is this angle here. If I give my answer correct to one decimal place, then I'd get 5 marks. So with this question, the first thing I'm going to do is I'm going to use Pythagoras to find the size of this line segment here from A to this right angle here. Okay, so once I've found that, then I'm going to find the size of this line segment here, from here to here. When I've found that, then I can find the angle CDA. Okay, so let's do that now. So I'm going to split the diagram up, okay, into different sections. So the first thing I'm going to do, I'm going to draw a line down here from C to this point here, which I'm going to call E. Okay, that line is parallel to this line, and they're all right angles around here. So this is 6 centimeters. So this will be 6 centimeters. The next thing I'm going to do is I'm going to label this point here F, and I'm going to find the length of AF. Okay, so the length of AF, I can find that using Pythagoras, since I'm given this right angle triangle here, and I know the longest side, the hypotenuse here, and I know one of the shorter sides. So I can use Pythagoras. If you're not sure how I've done that, just look back on my video clip on Pythagoras on my YouTube channel. So using Pythagoras, I can find that AF equals 4.5. Since I now know AF, I can find DE, so this line segment here. This is 4.5, this is 10, and the whole thing is 24. So if I subtract 4.5 and 10 from 24, I'll get 9.5 for the length of DE. Now to find angle CDA, so this angle here, I know this is 9.5 and I know this is 6. So essentially, this right angle triangle, I can apply trigonometry 2. This side here, from the point of view of this angle, this side is the adjacent and side is the opposite. So the opposite and adjacent are related using the tan ratio. So the tan is equal to the opposite divided by adjacent, which is CE divided by DE, which is 6 divided by 9.5, and then doing the shift tan of that on the calculator will give me an angle of 32.3 degrees, and that would be 5 marks for the whole question. Question 16. I'm given a circle and an equilateral triangle. One side of the equilateral triangle is the diameter of the circle, and you can see that here. It goes through the middle, it goes from edge to edge. I'm told that the circle has a circumference of 44 centimeters. So that's the distance all the way around that circle. I have to find the area of the triangle. Okay, I need to give my answer correct to 3 significant figures. So with this question, the topic here involves circumferences of circles. So if you're not sure how to find circumferences of circles, then look back at my video clip on circumferences of circles on my YouTube channel. Now the first thing I'm going to do here is I'm going to find the radius of this circle. To find the radius, okay, I know that the circumference is given by 2 pi r. So since the circumference is given by 2 pi r, and I know the circumference is 44 centimeters, 44 equals 2 pi r, and then making r the subject of that equation, I can do 44 divided by 2 pi, which gives me 7.002. So the radius is 7.002. The radius is from the center to the edge of the circle. So that's the radius there. Now, if I draw a line down vertically from the top of this equilateral triangle straight down to the center here, I'm forming 2 right angle triangles. So let's focus on this right angle triangle. This here must be a right angle, since this and this line are perpendicular to one another. So to find the height of this right angle triangle, I know that this angle is 60 because this is an equilateral triangle. So I can apply trigonometry knowing that this side is opposite to the angle and this side is adjacent to the angle. So I can use the tan ratio, tan equals opposite divided by adjacent. Substituting in the value of the angle, 60 degrees, and the value of the radius, 7.002, which I found earlier, I can find the height, which would be 12.13. So the height of that triangle is 12.13. Now to find the area of the triangle, I can now quite simply do base times height divided by 2. I can apply that to this small triangle here, and then I can just double it because these 2 triangles are equal to one another. So base times height divided by 2. So the base is 7.002, that's the radius there. The height is 12.13, and then if I double that for both triangles there, I get 84.9 centimeters squared. The whole question there is worth 3 marks. If you're not sure on how I found the circumference and the radius earlier, then look back on my YouTube channel on areas and circumferences of circles for that video clip. Question 17. A, B and C are points on a circle of radius 5 centimeters and center O. DA and DC are tangents to the circle. So these are tangents to the circle here. And DO equals 9 centimeters. But that's not labelled on the diagram. So I'm going to write that on the diagram in a minute. Need to work out the length of the arc ABC. So this arc around here. Give your answer to 3 significant figures. And this question is worth 5 marks. So for this question, what I'm going to do first of all is I'm going to find the angle AOD. AOD is this angle here. I can find that using trigonometry. When I found that, then I'm going to find this angle around here, this reflex angle, using knowledge about angles around a point. And when I found that, then I can find the arc length of ABC. Okay, so this topic does involve arc lengths. If you're not sure on how to find arc lengths, have a look on my YouTube channel on the video on arc lengths, and that would help you. So let's label on this diagram that value of 9, okay, because it tells you that DO is 9 here. It also tells you that this is a tangent to the circle and this is a radius. Using our knowledge from circle theorems, the tangent and the radius always meet at 90 degrees. If you're not sure on how I've achieved that, again, look at my video clip on circle theorems on my YouTube channel. So we're now given a right angle triangle. Okay, this side is 5, that side is 9. So I can now find angle AOD, which is this angle here. From the point of view of this angle, this side is adjacent and this side is the hypotenuse. Adjacent and hypotenuse are related using cosine. So cos is adjacent over hypotenuse. The cos of this angle is AO over OD, which is 5/9. Shift cos would give me 56.25 degrees. So angle AOD is 56.25. This angle underneath here, which is angle COD, so COD would also be 56.25, since these two triangles are identical, since they've got identical radii here and the tangents are equal in length and they've both got right angles here. So this angle here is also 56.25. So 56.25 are here and here, and all around this point we know that angles, the sum of angles around a point is always going to be 360. So to find this reflex angle here, I can do 360 subtract 2 lots of AOD. That gives me 247.5. Now the next part of this question, I'd have to find the arc length of ABC. The arc length is given with this formula here. The angle at the centre of the arc as a proportion of 360 degrees times by the circumference of the whole circle. So following that through, the angle is 247.5, divide that by 360 and times by 2 pi r, I'll get 21.6, and that whole question there is worth 5 marks. Question 18. I'm given a diagram here and I'm told that OAC is a sector of a circle, centre O and radius 10 meters. I'm also told that BA is a tangent to the circle at point A and BC is a tangent to the circle at point C. Angle AOC is 120 degrees. So I've got to find the area of this shaded region to 3 significant figures, and this whole question is worth 5 marks. So for this question, the topics involved are clearly trigonometry, but also circle theorems and areas of sectors. So for this question, if you're not sure on circle theorems or areas of sectors, make sure you look at those video clips as well on my YouTube channel. First thing you need to know from circle theorems is that a tangent and a radius always meet at 90 degrees. So this would be a 90 degree angle here and here. So let's label that on. Here's my right angle triangle. Essentially, if I draw a line from B to O, I can form a triangle on this side and a triangle on this side. Since that bisects the angle here, this would now be 60 degrees here. So looking at this triangle on the left hand side, I can find the length of AB. AB is given through this trig ratio here. The tan of this angle 60 is given by the opposite side, which is AB, divided by the adjacent, which is 10. Since I know the tan of 60, I can find AB. If I rearrange this equation, AB would be 10 tan 60, and that would give us 17.321. The next thing I'm going to do is I'm going to find the area of ABCO. Since ABCO is essentially 2 triangles, and I know the base of each triangle, and I now know the height of each triangle, I can just use half base times height. I can double that to find the total area of this entire shape. Substituting those values for AB in and AO, I can find that the total area of this entire diagram is 173.21. The next thing I'm going to do is I'm going to find the area of the sector AOC, so this white sector here. The white sector here is essentially just part of a circle. So if I can find the area of the circle using pi r squared and then find the proportion of 360 degrees, which this angle is, I can find the area of this sector. Essentially, the formula is here. The angle at the centre of the sector divided by 360 and times by the area of the circle. That would give me 104.72. So I now know the area of the entire diagram and I know the area of the white sector. I can now subtract those to find the area of the grey shaded region. And that there is simply 68.5 meters squared to 3 significant figures. The whole question there is worth 5 marks. Question 19. Here are two right-angled triangles. Given that the tan of E equals the tan of F, find the value of X. You must show all your working. So this question is worth 5 marks. Essentially, I've got two different right-angled triangles. What I'm going to do in this question is I'm going to use this fact that the tan of this angle equals the tan of that angle there. We know that the tan is given through the ratio opposite divided by adjacent. So this ratio is what I'm going to be working with. If I apply that ratio to this left-hand triangle, the opposite is x and the adjacent is 4x minus 1. So x over 4x minus 1, and that would equal the opposite for this triangle, which is 6x plus 5, all divided by 12x plus 31. If I then cross multiply, if I multiply both sides by 12x plus 31 and both sides by 4x minus 1, I end up with this equation here. Then if I multiply out the brackets, expanding those and then getting it in the form of a quadratic. If you're not sure on how to solve quadratics, then do look back at my video clip on solving quadratics on my YouTube channel. I can essentially solve this by factorising. When I've factorised it, I can then say that this is not a possible solution since it's negative. And you cannot have a negative length. Remember, x represents a length. So this must be the only plausible solution. So x therefore equals 5/3. The whole question there is worth 5 marks. Question 20. I'm told that I've got a metal rod AB which is resting inside a cylindrical tin. The tin is on a horizontal table. AC is the diameter of the base of the tin. B is on the top edge of the tin. BC is vertical. The radius of the base of the tin is 5 centimeters. The volume of the tin is 1178 centimeters cubed. Find the angle between the rod and the base of the tin, giving your answer to the nearest degree. So in this question here, this involves the volume of prisms. Okay, so I need to know the formula for the volume of a prism, in specifically a cylinder. I'm going to find the height using that formula. Then when I found the height, I can then find the angle which is between the rod and the base of the tin. And for that I'm going to use trigonometry. If you're unfamiliar with how to find volumes of prisms, do look back at my video on volumes of prisms on my YouTube channel. Essentially, this is the formula I need to use. The volume of a prism is given by the area of the cross section times by the height. The cross section here is a circle, so the area of a circle is pi r squared, and I'm going to multiply that by the height. Since I don't know the height, but I do know the volume and I do know the radius, I can work out the height by rearranging the formula. So substituting in the volume, substituting the radius, and then rearranging would give me a height of 14.9 centimeters for BC. Now to find angle X. Angle X is the angle between the rod and the base of the tin here. Okay, and this base of the tin is at right angles to the edge of the tin here. Therefore, this is a right angle triangle, and therefore I can apply trigonometry. From the point of view of the angle, okay, this length BC is opposite, and the diameter here, AC, is adjacent. Since this length BC I worked out earlier as 14.9, and the diameter is just double the radius, which was given to me earlier, by substituting those values in, I can find the value of X by using shift and tan. So that there would give me an angle of 56 degrees to the nearest degree. The whole question there is worth 4 marks. Question 21. I'm given a triangular prism. The base of the prism is a square of side length 15. Angles ABE and CBE are both right angles. Angle EAB is 35 degrees. M is a point on DA such that DM to MA is 2 to 3. Calculate the size of the angle between EM and the base of the prism. Give your answer correct to one decimal place. So let's just draw on that point M. There's the point M there. Okay. And there's the angle I need to find. Okay, it's between EM and the base of the prism. So this is the angle X bar I need to find. The way I'm going to do this question is, first of all, I'm going to find EB. EB I can find using simple trigonometry. When I found EB, then I'm going to find the length of MA. Once I found MA using the ratio here, I can then find the length of BM using Pythagoras. So BM can be found using Pythagoras. And lastly, I can find the angle X. So let's do that now. So EB. EB is just this length here. So if you ignore the rest of the diagram, EB is quite simply from this right angle triangle. It's the opposite side to this angle. And I'm given the adjacent to the angle. So the opposite and adjacent are related using the tan ratio. So the tan of the angle is opposite divided by adjacent. So the opposite must be 15 times tan 35, which gives me 10.503. Now, I'll need that later on, but in the meantime, I'm going to find the length of MA. Since I know that there's 5 parts between DM and MA in this ratio, and I know that the whole length of D to A is 15 centimeters, I can then do 15 divided by those 5 parts, so each part is worth 3. If each part is worth 3, then I know that MA is going to be 3 lots of that 3, which is 9. So MA is 9 centimeters, and obviously DM would be 6 centimeters, which adds up to 15. So there I found MA, and earlier I found EB. The next part of this question is where I'm going to find BM. So BM, as a reminder, BM is this length here. I can find BM since this length AB and AM are at right angles. So if I imagine now drawing a plan view of this triangle here on the base of this prism, this is what I'd have. I'd have AB as 15 and MA as 9. To find the length BM, just apply Pythagoras. If you're not sure on how to do that, look back at the video on Pythagoras on this channel. BM becomes 17.49 centimeters. The next thing I'm going to do is I'm going to find the angle X, and that's what I'm asked to find for the final solution. Angle X I can now find since I know BM and I know EB. So if I just imagine this triangle now and I redraw this for the angle X. So BM is 17.49 as found a minute ago, and EB I found earlier. The angle is given through the tan ratio since I know the opposite and I know the adjacent. Dividing those through values through, I get 31.0 degrees, and that would be to one decimal place. The whole question there is worth 4 marks. Question 22. I'm given a solid pyramid here. I'm told that the base of the pyramid is a square of side 20 centimeters. The angle between any sloping edge and the plane ABCD is 55 degrees. I'm asked to find the surface area of the pyramid, and I need to give my answer correct to 2 significant figures. So the way I'm going to approach this question, I'm going to imagine the center of this base directly underneath V. I'm going to call that point X. Imagine that's point X there. And then in this question, I'm going to find the length of AX. Once I've found AX, I'm then going to find VX. Having found VX, I'm going to find MV. MV is this distance here along that sloping edge. Once I've found MV, I'm then going to find the area of one sloping face. I'm going to find the area of the base, and using those two values I can find the total surface area. So let's follow that through now. Imagine this is the base of that pyramid. So this is the base of the pyramid. I've got the vertices A, B, C, D here, and in the middle I've got X as I've labelled it here. So to find the length AX, I know that this is essentially a square of side 20. Since X is the middle of this entire square, I know that this side of this right angled triangle will be 10, and this would be 10. Essentially this is a right angled isosceles triangle. Using Pythagoras, I can find the length of AX, which would be 14.1. If you're not sure on how to use Pythagoras, do look at the video clip on this channel. The next thing is to find the length of VX. VX is essentially the perpendicular height of this pyramid. The perpendicular height is given, if you imagine this triangle here, this is the center of the base of the pyramid, this is the apex of the pyramid, and this is point A. So essentially it's this triangle here which I'm looking at. Again, it's a right angle triangle since this base is parallel to the ground and this is the vertical height. So since it's a right angle triangle, I can use trigonometry, and this angle is related to Vx and Ax using the tan ratio. Since Vx is the opposite and Ax is the adjacent, I can substitute those values in, and I can substitute in the angle of 55 which I'm given in the question here. So following that through and rearranging, I can find that Vx is 20.19. The next thing to do, once I've found Vx, is to find MV. MV is the length of this sloping edge here from the base to the apex. So MV I can find quite simply by redrawing this as a right angle triangle. There's point V, point M, and point X is the center of the base there. Since I know Vx from earlier as 20.19 and I know Mx is just 10, which is shown on this diagram here, I can use Pythagoras to find Vm as 22.54. The next stage is now just to find the area of one sloping face. So I can find the area, for example, of this sloping face here, ABV. To find the area of this sloping face, it's essentially a triangle. And the area of a triangle is given by half base times height. Well, the base is AB and the height is MV. And since I know AB is 20 and I know MV is 22.54, I can find the area of that triangle. Half base times height, that gives me 225.4. That is the area of one of those sloping faces. To find the area of the base, that's quite simple. The base is just a square, so it will be 20 times 20. So that will just be 400. To find the total surface area, the total surface area of course is all four sloping faces which are identical, plus the area of the base. Adding all those up, I got 1300, and that would be to two significant figures. The whole question there is worth 5 marks. Question 23. Like the previous question, I'm given a pyramid with a square base ABCD. I'm told that AB equals 5 meters and the vertex T is 12 meters vertically above the midpoint of AC. Calculate the size of angle TAC. TAC is this angle here. So if I just label up that pyramid with those measurements there. So I'm calling the midpoint of AC point M. Okay, and this is the angle I need to work out here. Here's the 12 meters labeled vertically above the midpoint of AC. And so this here must be a right angle since AC is horizontal and TM is vertical. So to find AC, I'm going to use Pythagoras since AC is part of a right angle triangle, since ABCD is all of a square. So quite simply, I've got a right angled isosceles triangle here, and using Pythagoras, AC would be 7.071. If you're not sure on how I've used Pythagoras, look back at my clip on Pythagoras on this channel. To find AM, which is this length here, AM is quite simply half of AC, since M is a midpoint of AC. So AM would be 3.535. To find angle TAC, I need to use trigonometry. So applying trigonometry, I know that TAC, the angle A, I've got TM, which is opposite to the angle, and I've got AM, which is adjacent to the angle. Since those two are related using the tan rule, I can then substitute those values in, and using shift tan, I get this answer of 73.6 degrees, and that would be my 4 marks for that question. Question 24. ABCDEFGH is a cuboid. AB equals 7.3, CH is 8.1, and angle BCA equals 48 degrees. I have to find the size of the angle between AH and that plane ABCD. I have to give my answer correct to 1 decimal place, and the whole question is worth 4 marks. So just labelling on those dimensions onto the diagram, I get this. So here's CH as 8.1, here's AB as being 7.3, and angle BCA is 48 degrees, which is this angle here. The angle I'm trying to work out is the angle between AH and the plane ABCD. So the first thing I'm going to do is I'm going to find AC. Once I've found AC, I can then find the angle X. To find AC, well, AC is part of a right angle triangle. Okay, and the right angle triangle is shown here. I know that the sin of ACB is related with the opposite and the hypotenuse. If I do the opposite to the hypotenuse, then that's the length of AB divided by the length of AC. Since AB is 7.3 and the angle is 48 degrees, by substituting those in and rearranging, I can find the length of AC. So AC would then therefore be 9.823. Next, to find the size of angle X. Well, angle X is related to CH and AC through the tan ratio. So CH, you can see here, CH is opposite to this angle and AC is adjacent to the angle. And I found the length of AC just a minute ago. So substituting those values in and then pressing shift and tan on my calculator, I get 39.5 to 1 decimal place. So that would be my answer for 4 marks. If you need any more support on these sorts of questions, be sure to check out my clips on Pythagoras, which is also on this channel.